Alright, so let's say I spotted an enemy target right there. There we go. See? It works perfectly.
Tanner. Hello, this is Tanner Tech.
Alright, so this is the box that was sent to me by Banggood, and it has my controller and RC car inside it. So I say we crack this box open. It is covered by tape, so I'm going to use my knife, see if I can get in there. Alright, so the first step in the process to building this RC truck that has a coil gun on top of it is to actually build the RC truck. So this is the truck that Banggood sent me, and it'll be a lot of work to put this truck together. So I'm just going to make a quick time lapse of this happening, because there are a lot of parts. And then I'll explain it a little bit after it is all finished. So, let's get started. Alright, so I finished building this car and I am extremely impressed with this kit. So this kit was super fun to build, and I'm just super impressed with all of the engineering that went into making this thing. So this isn't just any normal truck, it's a four-wheel drive truck with differentials inside it, and it even has the drive shaft that goes to the motor in the middle. The drive shaft turns both of the differentials so it can do four-wheel drive, and it moves. Another cool thing about this truck is it even has shocks. I'm not sure if you can see it right here, but there's little springy metal shocks, and because it has this special kind of drive shaft, the wheels can move up and down and the whole truck can bounce. So that way it can drive over rough ground and it can still move pretty well. So yeah, this is a really awesome truck. Now to build this, basically what I did is I followed the instructions. The instructions in here are very clear, and I was able to put these two metal rods on each side and bolt all the required parts to them. You have to first put together all the differentials and stuff with gears, but that's not too hard. And then you can do everything else. In fact, the front is also controlled by this servo, and because of that special drive shaft, you can steer both wheels like this, which is really cool, I think, too. So there you go. That is this truck in its glory. So, now that you've finished making the truck by itself, you need to add something more to drive it around, because by itself it doesn't drive. So that's what this is for. So, Banggood actually sent me this really cool controller too. It's a FlySky i6. Alright, so let's see if we can figure out how we can connect this controller to the DC motor inside this car. So the first thing you need to know is that this box right here is what connects to the controller. So whenever you turn something on the controller or move any of the switches or buttons, it sends a signal through the antenna on the controller to this receiver box. This receiver box has two little antennas on it, and it also has all these output ports on the side. Now these output ports output something called PWM, or pulse width modulation. Now usually you can use this pulse width modulation to drive servos or other motor controllers like brushless ESCs or DC motor ESCs, but currently I don't have a DC motor electronic speed controller, and I couldn't really find one online. So we're going to have to build our own using an Arduino, and we're also going to use the Arduino to power the coil gun circuit, and also to help with our speed controller. So let's take a look at how I did this. So what I've done is I've taken this little receiver, and I've wired each of the PWM outs to the Arduino. The Arduino is actually powering it too, and I also just put a servo there just for the heck of it. So as you can see, when I fire up my controller, move it back and forth, the servo moves. But then if we look at these numbers that are on the screen, we can see some other interesting things. As you can see, when I move the throttle up and down, you can see the middle number, which is the milliseconds between each pulse, or how long a pulse is on for. It changes from about 998 to a little under 2,000. So it goes from about 1,000 to 2,000. And if I flip these switches on the top, you can see that I can change that value from about 2,000 to 1,000. I can change this value with this switch from 2,000 to 1,000. So this is what we're going to be using to control this device. So I've got this switch right here. This switch is going to be forward and backward. When it's in the up position, I will move this throttle switch and the car will drive forward or backward. When I put it into the backwards position, I'll move this throttle switch and the car will drive backward. This switch right here will be to activate the coil gun. When I press it down, the coil gun will be triggered. So this is basically what you're going to need for this project besides the RC car. So you're going to need some high voltage capacitors. These are 400 volt, 120 microfarad electrolytic capacitors. These will help power the coil gun. You're also going to need your coil gun barrel. For this I'm using a pen tube with a coil of wire wrapped around it. This will accelerate the projectile. You're also going to need a silicon controlled rectifier, and I just dropped it. Silicon controlled rectifier is something that is able to dump all the power from the capacitors into the coil at one little bit without making a spark that wastes energy. You're going to need an XT60 connector to connect your drone battery to your RC car. You're going to need an Arduino to run everything. A little L298N motor driver. What this does is this is able to take the signals from the Arduino to drive the DC motor. You're also going to need one of these. This is the connector this is the receiver that connects to the controller. Finally, you're going to need these two servos. These two servos are going to drive the gimbal that runs the coil gun. Oh, last but not least, you're going to need a lot of wire. Alright, so what I'm going to do now is I'm going to write the code for the RC car. Alright, so now we've basically got everything declared in the top of what the different pins are, and we set those as outputs and inputs. Now what we're going to do is we're going to set a map function, so that way we can take the throttle, which goes between approximately 1000 and 2000. We're going to map that to 0 to 255, so we're going to take C3, that is the throttle pin, we're going to map that in a map function to 1000 to 2000. And we're going to map that to 0 to 255. And so basically this will set C3 to an analog write value that we can analog write to the output. So right underneath this, we're going to analog write that. We're going to do analog write. And then we want to do our speed pin. We're going to set that to C3. And that should complete our speed function. Actually, we're going to make this an if function. So we're going to do if, let's see, reverse and forward. So if C5 is greater than 1500, then what it's going to do is it's going to execute a function that digital writes a certain value. And actually, we don't even need those, because we can just add digital write and then do digital write forward low, backwards high. And we're gonna just copy and paste this in and just switch the values. And if we just switch this to high and low, we should get a program that will run the throttle of the L296 according to the code. Now all I have to do is kind of add something similar to this to fire the fire pin. Alright, now it's time to start wiring things up. So what I'm planning on doing is I'm planning on taking these little pieces of cardboard. These are going to serve as the mounts for the Arduino, RF receiver, and L298 motor driver. Now, let's glue these boards down and wire them up. So basically what we want to do is we want to connect channel 6 of the RF receiver to pin 7 of the Arduino, channel 5 of the RF receiver to pin 6, channel 3 to pin 5. I want to connect the forward pin or forward enable to 8, backward enable to 9, and PWM speed control to 10. And we'll just have a wire going from Arduino pin 11 to the fire pin of the SCR that will be controlling the railgun. That's it. So let's glue these things down. Here goes all the connections. This will take a while. Alright, so it looks like this new system works flawlessly. I have it hooked up to my bench power supply and I have my controller on. As you can see, when I turn up the power on the controller, it turns up the motor power. And if I flip the reverse switch, then it will reverse. Alright, now it's time to connect the motor to the control board, and I'll use my soldering iron for that. Without melting the axle, of course. Alright, here we go for the first test. Oh, it's going backwards. That's interesting. What in tarnation is going on here? Look at the wheels spin opposite directions. That's not supposed to happen. What the heck? Alright, so I discovered my issue with that previous test. So I was trying to drive the truck, and the issue was the rear differential was on backwards. And since I put the rear differential on backwards, both pairs of wheels turned in the opposite directions. And because of that, it would pop out these little couplings that attach the differentials to the drive motor. And it would just cause a wide variety of problems. It wouldn't even move forward because with both wheels spinning in the opposite direction, how could you expect that to move? So all I did was fix up the rear differential, and now it should work just fine. So let me show you a little example of this thing driving around. Alright, so I fixed some things in the code that needed fixing with this car. Well, the first thing I fixed was I set a constrain function inside the code, so that way any value on the remote control that's below a certain function will be returned as 0, because I was having issues with the thing randomly accelerating, and that random acceleration almost broke one of the little couplings that go from the main drive shaft to the differential. But now I think I've got it all working, and the controller is all smoothed out. So let's see this thing drive. Alright, enough of the boring stuff of getting this thing to drive. Now it's time for the cool stuff, adding electromagnetic coil gun turrets to this thing. So first of all, I'm going to take this little motor, and we're going to put some hot glue on it and stick it down. And this should give us one of the axes for our coil gun. So hopefully this should work out. I'm just going to put some hot glue here and let it dry. We'll see that is the first axis. Then I will add the second axis, which is this motor. And the motors are plugged into their respective ports on the RC receiver. And of course, they're all powered by the same power supply. And there we go. That is our second control axis. And then I can mount the actual coil gun. The coil gun is the coolest part. Alright, that's pretty cool. Check it out. I got the turret working, so now you can arrange the turret in any position you want. You can move it up, you can move it down, you can move it side to side. It's got a pretty wide range of actuation, and so this turret should be pretty cool in launching servos and launching projectiles. So what happens is after everything's all set up, and I have my capacitors charged and my silicon-controlled rectifier, all I have to do is arrange the turret and aim it, and then pull this switch to fire it, and it will fire whatever projectile's inside there. Alright, so this is the entire coil gun setup, and it has been correctly mounted and everything else. So in this setup, I didn't want to add another circuit that charged the capacitors because that would be too difficult. For now, I'll just be using my vacuum tube power supply down here, which can supply 400 volts to charge the 400 volt capacitors that will be used to drive the coil gun. Now basically how a coil gun works is you have this coil of wire around a pen tube, and you put some kind of ferrous object in the back that can be affected by magnetism. Then what happens is the turret can move around and aim, and then when you press a button on the remote control, the Arduino will send a signal through this wire into this thing called a silicon-controlled rectifier. That'll allow a large amount of current to flow from the capacitor bank to the coil of the coil gun, which will create an immense magnetic field for a brief second of time, which will accelerate the object into the middle of the coil. Then by the time it's in the middle, it'll have so much momentum that it'll just fly out and puncture whatever is in front of the truck. So I'm using 3 capacitors. These are 400 volt, 120 microfarad capacitors in parallel, which means it will be a total of 360 microfarads at 400 volts, which is a lot of power. I'm using a TYN 122.5 silicon controlled rectifier. That is attached to the capacitor bank, and it's in series with this coil gun. And that's just about it. Now in hindsight, I realized that I probably should add a opto-isolator circuit because you have the Arduino directly connected to the silicon-controlled rectifier. If anything were to short inside the silicon-controlled rectifier, it could possibly blow all my circuitry over here, including the receiver. And that would not be a good thing. So, right now I'm just going to test it without an opto-isolator circuit, but sometime in the future I may add one. So, let's give this a little test, but for now we're done. Alright, so as you can see, I have this little screwdriver bit. It's this sharp metal screwdriver. I will just set it inside the barrel of the gun, and if I tilt it back, you can see that it loads the gun, and then I can aim it and do that. So now let's charge the capacitors. Alright, so to charge these capacitors, what I'll basically do is connect a wire to the ground line of this capacitor bank, and then connect that to the ground line right here. Oh, I also disconnected the control wire from the SCR, so this thing's physically isolated from the Arduino circuit with the exception of the common ground. And so I have my voltage, my multimeter right here measuring the voltage of the capacitor bank. So I'll connect this to positive, down there. And I'll connect that to the positive part of the capacitor bank. As you can see, the voltage already jumped up a bit. So now watch what happens when I charge up the capacitor bank. Ooh, that's what I like to see. Look at that voltage. 260 volts, 270, 280. Yeah, let's kick this thing into high gear. There we go. That thing is pretty charged. So now let's test this out by connecting the silicon controlled rectifier very carefully. And now I will use my controller to see if I can fire this cannon. So I will aim it. Oh, that works awesome. Alright, I'll stand back so you can watch me control it on my remote control. So as you can see, I have the switch in the down position, that's fire, so I'll put it into up, which is safety mode. I will charge the gun. Right now it's at 270 volts. I'll tilt it up, so that way it slides the projectile back, and then I can move it around to aim it. And then once it's aimed, I can fire it. And it's pretty cool. Alright, let's drive this thing around. So I can... First, let me move this out of the way. Oh, that's not good. And watch this. When I want to kill that device, alright, so let's say I spotted an enemy target right there. There we go. See? It works perfectly. Alright, so that's it. Thank you so much for watching. That is how you can build a cool car that has a DC motor control system that works with a remote control receiver from a remote, and it uses an L298 motor driver and an Arduino to control different motors, and it uses a capacitor bank and a silicon controlled rectifier and some servos to fire some cool projectiles. So this is a really cool little toy to play with. These projectiles are not dangerous. They basically go the speed of a Nerf dart, and they can't puncture skin or anything, so this is pretty safe. If you put more capacitors and a better coil on here and more voltage, then you could get something that would be dangerous and more stages in the coil gun, but for now it's pretty safe. And now you can check the links in the description to buy that remote and to buy this car kit from Banggood.com. And as always, thanks for watching and stay tuned for next time.